When you think about blockchain, probably the first thing that comes to mind is Bitcoin or cryptos. But actually, the technology has so much more potential beyond cryptocurrencies. Blockchains have become popular because they allow us to secure and verify all kinds of data in a decentralized network that cannot be altered. The idea has its roots as far back as 1991, when two scientists, Stuart Haber and Scott Stornetta, proposed a system to protect timestamps on documents from being interfered with. Satoshi Nakamoto then built on this system. He deployed the first public blockchain when he invented Bitcoin in 2009. Put simply, a blockchain is a database in the form of a distributed ledger that uses cryptography to secure any kind of information. This ledger takes the form of a series of records, or blocks, that are each added onto the previous block in the chain. Hence the name blockchain. Each block contains a timestamp, data, and a hash. This is a unique identifier for all of the contents of the block, sort of like a digital fingerprint. The block also contains the hash of the previous block in the chain, but we'll come back to hashes in a second. Crucially, once data has been recorded and verified in a block, it cannot be altered. Instead, if a change has to be made, this is recorded and verified in a new block added to the chain. Therefore, each new block reinforces the verification of the previous block, and hence the entire blockchain. Now, let's get back to hashes. These are the backbone of blockchain technology. It's how all the participants in a public decentralized network can agree on how a block is verified and added to the chain. A cryptographic hash function is basically a mathematical algorithm that maps data of arbitrary length to an output of fixed length. So, if you want to represent, for example, a list of names of varying lengths, a hash function would output each of these names, the data, into a unique string of numbers of a fixed length. This string of numbers is known as the hash. The hash function will return the same hash no matter how many times you input the same data. If you even slightly change the inputted data, the hash will change completely. Hashing is considered a function that only works one way. That's because it's highly infeasible to reverse engineer the data that outputs a given hash without a huge amount of computational power. Infeasible, but not impossible. The fastest way to guess the data that produces a given hash is simply to guess and check. Again, and again, and again. In the Bitcoin blockchain, computers in the network join in this elaborate guessing game, hoping to solve the puzzle first. Here, the computer with higher computational power, meaning the capability to run through more guesses faster, is more likely to win the race, and therefore verify the block for the reward of Bitcoin. It's important to remember that the word blockchain doesn't describe any single database or network. Rather, it's a type of technology, and there are different kinds of blockchains that work in different ways. A public blockchain like Bitcoin allows anyone to join the network and access the distributed ledger. A private blockchain is a closed network. It still uses some decentralization and a peer-to-peer system, but overall, this kind is controlled by a single entity, and access is restricted to a defined network. A hybrid blockchain is a combination of a public and private blockchain. This kind of blockchain allows an entity to distribute a ledger with some publicly accessible data, but also restrict access to more sensitive data within the network.
Think of a blockchain as a place where you put data into in a way that it can't be later on tampered with or changed. And so you can imagine that a blockchain is useful anytime you have any sensitive data or important data that you care about that you really want to make sure is always represented very accurately. Currencies are certainly one such type of data, but there's certainly other data as well. Increasingly, people have used the state of a program, the actual program itself, as something that they want to put into one of these blockchains and have effectively run in a way that can't be tampered with. There's a phrase for this called smart contracts, and increasingly a lot of new blockchains are allowing you to effectively program them in a way that can't be tampered, in a way that can't be changed.